With more data centres in the UK and Europe adopting gas generators, I explore with John Kinstrie, Energy Solutions Director at GTGen, what's driving this shift, the risks of reliance on gas, and whether these systems can meet the demands of modern data centres while supporting net zero goals. So, hello, John, and welcome to the interview. How are you today?
Good, Rebecca, thanks. Good.
So, my first question to you is why do we see a heightened discussion around the use of gas generators in data centre environments?
So grid connections have now become a major issue for data center operators. Many large power applications are now being rejected or they are subjected to very, very long waiting times and grid connection queues. So why's that happened? Well, quite simply, demand has massively outgrown capacity due to various factors. So if we look at the UK as an example, the UK's got a massive electrification push going on. There's the rise of the electric vehicle and the charging infrastructure associated with it. And of course, data centres have taken a lot of capacity from the mains network. And again, a more recent boom by AI rollouts is causing that demand. So really, in summary, capacity is extremely restricted right now in the UK network. So how does that translate to data centre operators? It's quite simple. No power really means no site. So why are they turning to gas generators? Well, gas generators offer that vital solution. So they enable the operator to secure continuous independent power without needing to wait years for grid updates or connections. Gas generators can run off a very reliable gas mains and allow more or less an immediate rollout of a data centre without any dependency on an overstretched or simply unavailable grid connection. So that's our take on what's going on at the moment.
Doesn't relying on mains gas make the data centre vulnerable to a gas supply interruption?
That's certainly a valid concern. It really is a valid concern. But what is important to note and highlight, and again, I'll base it on the UK in particular, gas mains network in the UK is actually one of the most reliable utility infrastructures in the world. It's got a documented uptime of around 99.9%, which means on average, unplanned gas interruptions on mains occur only once in every 140 years or so. So really, in comparison to the UK electricity network itself, it really is not that dissimilar. So there isn't much change between gas mains reliability and electrical reliability in the UK.
I've also heard gas generators struggle with sudden load changes. Can they really support data centre loads?
Gas generators do have slower load acceptance compared to a diesel generator, as an example. But what is worth looking at is most data centre applications, the concern is far less critical, as data centres typically have a very stable and consistent electrical load profile. Where that would be a concern is if you are running in an island mode in an industrial and manufacturing type sector where you've got large motor loads applying, motor loads starting, but for data centres that simply isn't the case. What is worth pointing out though is that most sites will still have some form of mains availability connection, which means that mains supply can certainly handle any sudden load steps and the gas generators can supply that base load power, all in synchronisation of course, not operating as two different electrical systems. If you did have load acceptance concerns and you didn't have any main supply whatsoever, it's actually a prime example where a hybrid system kind of comes into its own. So if you were to pair those gas generators with a battery, as an example, with a battery energy storage solution, that would fully take care of that concern. So in that example I gave about the mains being the buffer, the battery could be the buffer. But in reality, in most cases, gas generators alone will be more than capable of supporting a data centre due to their continuous and steady load profile. So yes, it's something that should be incorporated in the design review, but 99% of data centres, I don't think it will be an issue.
That's interesting. And so continuous operation must mean heavy maintenance. How can a gas energy centre still guarantee uptime?
Yeah, good question. What the key point there is really gas generators are built for continuous operation. It's what they're designed to do. But what Alongside that, what we do and what you need to ensure is that they're proactively monitored. So we real-time monitor all our gas engines that are out there in the field. And what you really need to ensure you do is predictive maintenance, not reactive maintenance. That's really, really important. You need to do predictive maintenance, so you replace the parts and components before they fail. You don't react to the failure. So that's really, really important. Another key consideration, and it falls into the system design, is system redundancy. So system redundancy plays a large role in this. So typically deploy an N+1 through multiple smaller units, which basically means if one unit needs servicing, the others pick up the load. So again, if you're looking at kind of guaranteeing that uptime, that modular approach paired with that predictive maintenance and real-time monitoring does allow prime use of gas generators to meet the highest uptime standards of Tier 3 and Tier 4.
And so are diesel generators still required if gas sets are running 24/7?
This is a point and a question that does come up that we want to be really clear on a position within DT Gen, and that's a yes to that question. It's an absolute yes to that question. Diesel generators remain essential for data centre backup. What we're proposing and what's happening is gas generators are replacing the grid as the primary source, but certainly not the backup source. So diesel generators are still the most reliable safety net for data centre operators. It does protect them from unseen emergencies or maintenance events. And really, in our opinion, diesel generators have rapid response time. They're very simple. It really makes them the gold standard for us for ensuring power continuity in critical situations like a data centre. So really, in summary of all that, yeah, they're absolutely still required.
Obviously, gas is a fossil fuel. How can this solution align with net zero goals?
It really is a fossil fuel, but our view is that it needs to be considered also as a transitional fuel. So it's not quite as simple as labelling it as a fossil fuel. So we look at gas as a transitional fuel. If you look at today's energy markets, you can already get green gas contracts or blends of such, which would immediately reduce the carbon impact of using gas generators for prime power. So if you actually look at that, it's certainly not as big a concern as you might think from the offset of a project. But more than that, and it's worth noting that as our clients progress in their net zero journey, additional fuel blends or even fuel types can be introduced. So if we look at that as an example, day one, we start with fossil fuel mains gas. Let's say after year one, we introduce a 10% blend of biomethane. So we're putting a 10% blend in there of green gas. That has a carbon reduction. Year two, we can look at increasing that blend, and we do that so on, and we match that blend and that transitional fuel, the transitional blending to the client's journey and more importantly, their net zero timeframes. So that is a key one, is you don't need to go full green gas from day one. You match it to the net zero targets and timeframes. Another point worth pointing out is that our engines, like most modern units, can already run on 100% green gas. No system modifications required whatsoever. So you'll hear a lot in the industry about future fuels ready, hydrogen ready, but most engines, modern engines, can certainly run on 100% biomethane at the moment, so they can run 100% on a biogas. But what is key to point out, as those future fuels become available, such as hydrogen, these blends can also be introduced at limited quantities. So in summary, yes, gas is a fossil fuel, but it certainly is a transitional fuel which does support clients in achieving their net zero targets. You just need to look at it over the time frame of the project.
Great, thank you so much for those insights, John. Is there anything you would like to end the interview with?
No, I don't think so. I think one thing I would just like to cover is that a question that does often come up is this solution short-term fix or is it a long-term strategy for data centres? And I think it's a very, very good question, and you'll have people with different takes on it, but certainly our view at DT Gen is right now it solves that immediate grid connection crisis, gets data centres online, again that no power, no site scenario. Longer term, I do, and DT Gen certainly do, think that it remains a vital component, but I do think longer term they'll be running on 100% green gas, and I think they'll form part of a wider hybrid ecosystem, energy system, so that could be renewables, batteries, gas gen. So I think that's the longer term strategy, because in our view and what we see with grid applications, that's certainly not going to be resolved in the short to medium term. That's going to be there for a long term. So yes, on my own question, I think it's a short and long term strategy fix for data centres.